This video will discuss creating custom fluid files in Microsoft Visual Studio for use in CoilDesigner software. If you are following along with this video, you must have Microsoft Visual Studio downloaded. These custom fluid files will be created as DLL files, which are external libraries which can be used to reference the fluid and all its properties in the CoilDesigner software. To begin, select Create a New Project. Then you will select the project type. The project type must be C#, class library with a .NET framework. It is important to select a .NET framework rather than a .NET standard because the CoilDesigner software also operates using a .NET framework. Once you have selected the project type, you may name it, choose its location to be saved, and select its framework. It is crucial to select a .NET framework of at least 4.7 because the current iteration of the CoilDesigner software runs on a 4.7 .NET framework. Any .NET framework that is less than 4.7 will not be operational in the CoilDesigner software. Once you have made all of these selections, press Create, and Visual Studio will generate your file. Your file will have three main windows. The first and the largest is the window where you will actually do your coding. Beneath that is the output window where, once you are ready to release your file, the output information will show itself, and during the coding process, any errors or warnings will appear and disappear as they are created and solved in this box. To the right is the Solution Explorer, which acts somewhat like a table of contents for your project. The first thing to do when creating a custom fluid file is to go to the References tab in the Solution Explorer and right-click and press Add Reference. Another way to accomplish this is the Project tab at the top of the window and press Add Reference there. We are going to add a reference to an existing DLL file that comes packaged with the CoilDesigner software. This DLL file contains skeleton code that will help us create our custom fluid. To find it, select Browse. Navigate to the CoilDesigner 4.7 file on your device and scroll down. Select the umdcee.common.dll file. Press Add, then make sure that file has a checkbox next to it, and press OK. If you have successfully added the file, you should see its name appear in the list under the References tab. Now that you have successfully added your reference, it is time to actually reference it in the code. Go to the first line with public class class1 and add a colon. Now start typing UMD. As you type, if you have successfully added the reference file, drop-down menus should appear, which will greatly speed up the coding process. Select the UMD-CEEE option and press Enter. Add a dot, and now select the Fluids option because we are creating a custom fluid. Add another dot and choose the IPTP properties. This is the interface that we will implement to give us the skeleton code. Once you have selected this value, the whole line of code you just made should turn red. If you mouse over it, you will see that the error here is that you have selected this interface but have not yet implemented it. To implement it, go to this light bulb with an X in it and press the down arrow. You will select Implement Interface If you mouse over the option, you will see a preview of what the interface looks like. To select it, click or press Enter. And as you will see, a list of methods appears in your code. These methods, with the exception of one, do not explicitly return any values. 3 of the 4 methods deal with finding various fluid properties that describe your fluid that you will use in CoilDesigner. The first method deals with the fluid's name and is the only one to explicitly return a value, because in the CoilDesigner software, when selecting your fluid, its name is the only thing that appears explicitly in the software. Each method gives you, in the parentheses, a list of inputs with their data type and variable names that you will use. We will not go through in detail how to code the various methods that get the fluid properties, because to code them robustly, you must design functions that will be able to calculate these properties at a variety of pressures and temperatures. However, we will explain how to do the fluid name. Because we need to return a string, we will create a string variable that I will simply call fluid name. We know that the data type of this variable is originally a refrigerant, so we can start typing refrigerant, then select it from the drop-down menu. Add a dot, and you will see a list of various refrigerants that are pulled from the umdceee.common DLL file that we referenced. If you select any of these refrigerants and mouse over it, you will see that simply inputting it would return a numerical value. We want to return a string, so even though we will select it, we will need to have additional coding. Select your chosen refrigerant, in this example ammonia, then add another dot. Here are some basic coding methods that are not pulled from the reference that we added. The method we will use is toString, which takes some kind of numerical parameter and converts it into a string. In our case, it will take the ammonia that we referenced and convert its numerical value into the string of its name. We'll select the toString method, and it is important to remember the 2 parentheses that go with it. At the end of our line, we will add a semicolon, and we should not see any errors. Then, we need to return the name of our variable, again with a semicolon. At this point, we should not see any errors in our code, and for the purposes of this example, we are ready to conclude coding. To take this Visual Studio file and turn it into the DLL file that we require for the CoilDesigner software, go to the top of the screen where it says Debug. These are the solution configurations that you can choose to conclude your coding and transform it into a DLL file. You may select either the debug function or the release function. The difference is that the debug function converts your code into a DLL file, but at the bottom in the output window will inform you of any errors or warnings that go along with your code. The release function simply converts the code into a DLL file without checking for any issues. For the next solution platform, we will select any CPU, then press the green arrow Start button. In the output screen, it will give us information about how our code worked. The first line contains information about the configuration of our DLL file. The second line gives its file path, which we will need to know to be able to upload it into CoilDesigner. The third line gives information about its success, possible failures, whether it's up to date or skipped. Once we have this file path, we can go ahead and reference this code in the CoilDesigner software. For more information about using the code in the CoilDesigner software, please consult the CoilDesigner help file, other tutorial videos, or contact support@optimizedthermalsystems.com.